well that you're recording this.
Yes. All right, so I think we can start. Thank you everyone for coming in. This one is close to the other one. We usually do them for the part of Francesco in town, and I said, you know, it's an opportunity that we don't want to miss. So thank you very much for coming and giving me stuff.
Thank you.
And we have Francesco, and after that, Buddy over there. We'll talk about ZeroMQ with Go, which is also a trending library, I think. You have the floor.
Okay, so hi, thanks for coming. So today I'm gonna, well, first of all, I'm Francesco Boy, and I'm a developer process engineer at for the Go team, and I'm based in Mountain and so not too far away from here. And today I'm going to be talking about 12 Go best practices. So since you're here, I'm not going to explain what Go is. Instead, I'm just going to try to explain what a best practice is according to Wikipedia, and especially what best practice is according to the Go community. So the idea is that through some basic techniques, we want to get code that is simple, readable, and especially maintainable. So I'm not using the word performant in here, and that's intended. Probably the code that you're going to end up writing might be a little bit performant than the original solutions, but it's way more maintainable. So it's always, you always have to find a sweet spot. So we're going to start by seeing some really beautiful code. So we have a Gopher, which is this track where we have some data about Gophers. So its name, age, and the color of the fur, which should be blue. And then we have a method which is non-binary, that given a writer, what we do is we write everything in binary. So we write first the name, then the age, and then the color of the fur into the binary, into the writer in binary format using little and get format. So here you can see that one of the things that is really not Go idiomatic is the fact that we have if error equals nil, and then we do something on that. Normally in Go we do the other way around. So we do if error is different from nil, because treating an error is normally faster and shorter. So that means that our code gets flatter. So if we do that, all of a sudden we get to this code, which is slightly better. But we can see that still, even if now it's way more readable, we're repeating things very often. So we're doing that binary.write with the writer and the little endian and some value 3 times, and we're treating the error every single time. So we can do better than that by deploying a one-off type. So this one-off type, I call it bin writer. Probably not the best name ever, but it's a writer that writes into binary, so why not? And it has 2 values inside, 2 fields. One is the writer we actually want to write into, and the second one is an error. And now we expose a method on that writer. And the method write, what it does is, if the error is not nil, it does something. Otherwise, so if the error is not nil, it doesn't do anything because something bad happened before. So we don't go on writing. And if the error was nil, we update the error with the result of writing something in little endian. Now, our code to dump binary is way shorter. So what we're doing is just creating our binary bin writer, and then just calling write, passing. So our string, we want to encode it encoding first the int32 length of the string, and then encoding all the bytes of that string. That's what we're doing. And then we encode the age and the fur color. And then we return the error that was kept inside of the bin writer. So this is the part where you say, this probably, not even probably, this is definitely less performant than the code that we had at the beginning. But this is also definitely way more readable. Now, there's still something that is a little bit dangerous. It's the fact that if you pass string, if you write a string into a binary using the binary.write, that will fail because you cannot encode strings that way. It's not available. So what we're doing is instead we're writing first the size and then all the bytes. But what if someone forgets? So it's better to have that logic inside of the write function. So that we can do it just using a very simple switch on the type of the variable. So if that v, which is an interface, the type is a string, then we get that as a string. We do the casting, and we know that that won't fail because otherwise we won't be here. And then we write the length and the value. And then otherwise we actually do what we're doing for.
You forgot the arrow.
No, because I'm doing w.write, so I'm actually writing the same
okay.
writer method.
Okay.
Yeah.
My bad.
So now in our code gets even simpler. Just we say, okay, I create my writer, and then I write the name, the age, the fur color, and that's it. So this is actually very readable now. It's pretty much the simplest thing that you can imagine to write a binary. Whoops, sorry. Now, there's something that we could simplify here. It's in here for the string, we're actually saying, if it's a string, take S as a string. And there's actually something that is a type switch with short variable declaration that it's part of the Go specification, but there's a lot of people that don't know about. And this is exactly what it is. So if you do this variable here, v will be a variable with the type of the interface that we got. Meaning that in this case, v will be declared as a string, and in this case, v will be declared as an empty interface because we cannot know which type it was. So now we have a little bit shorter code. Let me show you actually. Is this? Whoa, sorry. So this is something that just added. I think since we have time, it's interesting. Now we have this code here, the dumb binary, and we could imagine that now something that is happening is that if per color fails writing, and imagine that that writer is actually a network connection, we're gonna send the name, we're gonna send the age, and then it's gonna fail. And that's a pity. We send just half of an object, and we would like to just write either everything or nothing without changing this code much. And that's actually very easy to do since we have this type that is managing the way we write. So something that we can do is just add a buffer, a batch buffer, and when we write, actually our writer, it will change just this line, and instead of writing into the writer, it will write into the buffer. And by the buffer, the pointer to a buffer, it's also a writer, so you can use that too. Now, we need something else. That it's the fact that we're gonna do, at some point we're gonna flush and write everything into the actual writer. So I called it close. And what we do is, if there was no error, so if there was an error, we just return that. Otherwise, we actually write into the real writer, and we return the error of that. So now we just changed this BW close. Before it was just returning the error from that BW, the bin writer. Now we're actually calling close that returns an error. So now we know that just changing this little piece of code, our code is more correct because we'll only write when we know that the whole thing that we wanted to write is actually writable.
Doesn't it match there's a writer-closer interface in the IO library?
Yeah, it's a writer closer. So this could actually implement now, right? No, it couldn't implement a writer closer because this write is not the good signature though.
Oh, okay.
This is a write for interface, and it should be a write of a slice of bytes.
Okay.
Okay. Another place where we have also some repetition very often is when we have HTTP handlers. HTTP handlers don't allow you to return any errors, meaning that if you do something and it fails, and you want to handle that error in a nice way, so create a nice error page and log something, you should actually write that in every single case, or maybe just write a function to do this. But this is actually kind of repetitive, and what if you forget in one of the places? That's definitely not a very good practice to do this. So something that you can do, and that we do pretty often, actually I do it pretty much every day that I run an HTTP server, is having a decorator. So what we're gonna do is we're gonna write handlers in this way, which is exactly the same thing as before, but we allow this handler to return an error. So returning the error, it's actually simpler. Just say doing this failed, doing that failed, and otherwise we return nil. And now the important part is this error handler function that for a given handler that returns an error, it returns an actual handler function. So what we do is we call that function that we got, and if the error was not nil, then we handle that error. So you actually when you unify the error handling for all the handlers into one single piece of code. There's also something that we do very often that is very useful. It's the fact that instead of passing a response writer, just pass io.writer, and then the handler can do anything that it wants. But if you pass, instead of writing directly into the response, you could write into a buffer again. And if there's no error, then you actually write the whole object into the response writer. But if something fails, then you just return the error. This is actually very useful because if you're using templates, for instance, and the template at some point fails, you might write half of the template, then fail, set the error to 500, which doesn't work, of course, and then keep on adding some information, and you will end up with something that is not even valid HTML. Sorry.
I found out another trick for doing this. I usually make the error a variable and then have a defer clause, and only the defer actually write the data. So I have a buffer and an error inside the function.
Yeah.
And then I do a defer clause that checks if there was an error. Then
that's similar to what we have in the one before. Yeah. Yeah, that also works. Another way to do this that I've also seen is that instead of having a function, what you have is a type, which is this function here. So this being a type, and then you implement the method serve HTTP on that type, which then allows you to do HTTP.handle of that directly, because then it's a HTTP handler directly. So that's a different way. There's a lot of different ways to do it, depending on exactly what you want to do. Okay, now we're gonna see, we've seen a little bit just like basic things on little lines of code, how to import it. Now we're gonna see a little bit of how to organize code in general from a higher point of view. So first of all, inside of a file, the first thing that you should have is license information, copyrights, and these kind of things. Also build tags. So build tags, if you don't know what they are, they're actually very useful to build. So you can include or exclude the whole code in a file, depending on some flags of the platform where you're working. So for instance, you can say, I want to compile this only if I'm compiling this into App Engine, or if I'm compiling this in a version that has Go 1.1 or before Go 1.1. So you can have platform dependent code.
So if that's...
Yeah, but it's at file level only. Yeah. Sure. And then you have the package documentation. The package documentation that should be, of course, right before the package statement. Then we have all the import statements that we normally group by categories. So normally you have first all the packages that you import from the standard library, and then all the packages. You could have as many groups as you wish, of course. And the cool thing is that if you have this blank line here, GoFont will respect that and will order alphabetically inside of every group, keeping the groups as they are. And then the rest of the code, starting with the most important types. And the most important types are actually not the most important types for the package itself, but the most important types for the user of that package. So if the user starts reading your code, the most important things should be at the beginning, and then the implementation details should be at the end. Now, documenting your code is very, 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 very important, really. So
you missed the previous meetup that I exactly gave a talk about why you shouldn't write comments in your code.
Oh, really? Yes, we should talk about that later. So yeah, documenting your code, it includes a lot of different kinds of documentation, but one of the documentation is the documentation that is part of your code. And so this example that I was saying, where you actually give documentation about the package, so you have to write it right before the package playground without any blank line there. And then you should have also documentation for at least every single export identifier. Export identifiers are the ones that start with a capital letter. So in this case, author, or the method text element inside of author. And the cool thing about this is that once you've written this, then you can host your code anywhere, GitHub or Google Code, and then you will get generated documentation automatically for you. So this go.doc.org, and this is the documentation that was generated out of the code that we just saw before. So this is actually really useful for anyone using your package, and it's really simple to write, so it's definitely worth it. And if you click, then you get directly to the actual code of it. So for more information, these slides are actually online. I will write the link at the end. But this link links to blog posts about how to document Go code. So if you're interested, it's actually a pretty extensive one. Okay, sure is better, or at least longer is not always better. No, longer, yeah, that's it. So when you have a name, when you have to name things, and naming things is actually something really different, really difficult in computer science, and in Go, what we think is that names should be as short as possible, as long as they have the information that you want to express. So in the JSON package, we have this Marshall indent, and Marshall indent, which means Marshall with indentation. You could also call it Marshall with indentation, but the information that you're giving with one or the other is pretty much the same. And you have to think about people without code completion editors, so it's always good to have shorter names. And something that very often we forget is the fact that when you're using a type or a variable from outside of your package, it actually has to always have the package name. So for instance, if you're using a JSON package, inside there's a type called encoder, and it's not called JSON encoder. Why? Because outside of the package, you're gonna always refer to it as JSON.encoder. So JSON.JSON encoder doesn't help in any way. So this is actually something important. Having short names. Also the fact that thinking about the best short name for your package, also for your identifiers, also make you think about what exactly you're supposed to do. So very often, if you have a function that has a very long name, probably it's doing too many things. So good to think about it. And at some point, you may want to split your files and your packages into multiple files. In Go, you can have as many files per package as you want, as long as they are all in the same folder, in the same directory. So this helps you because it helps you keep files that are slightly shorter. If your file is too long, reading it could be tedious. And normally what you do is you separate it by semantics. So for instance, the HTTP package has 47 files, and you could find some things like connection or cookies or a lot of different things that handle different parts of the same package. Also, it's interesting to separate the code and the test. So for instance, in here we have the cookie.go and the cookie test.go. And they're both part of the same package. But in the cookie test.go, what we have is all testing code. And the interesting thing is that when you build your package, that testing code won't be compiled at all. It's only when you do go test that will will and run.
And we know what happens when you ship testing code to production.
Yes. So if you follow this best practice and put all the testing code in testing files, then you're good. And finally, when you have more than one file, it's sometimes difficult to know where goes the package documentation. So there's two different options. One is if you have a very clear entry point to your package, that could be the good one. That's no problem with that. But sometimes you have a lot of different files, and they're all part of a whole thing that by itself doesn't really make sense to document only one part of it. So what we do normally is we create this doc.go file, and what contains only one line of code, which is just the package and the package name, and then right before it's just a huge comment with all the information that you want to give about it. Okay, so something that is very useful is to make your packages go gettable. So what we mean by go gettable, it means that you could actually do go get and use them directly. So there's not complication of having, so if you have a main package on your go get and everything is inside of the main package, reusing that code is going to be very difficult. So it's always good to have, to separate the main package of the code that might be reused. And what we do very often is we have two different directories. One which is package, PKG, that contains all the things that you may eventually reuse in different projects. So in this example, I don't know if you've heard about Candy Store. This is the last project that Brad Fitz has been working on, and it's completely written in Go. And it's a very good example of how to organize different packages. And it has, so in the package directory, you find different packages. So the one about authentication, blah, bref, a lot of different things. And you can say blah, bref, test, and things like that. And then actually this program, it's a set of tools that you can use to upload and download objects to the cloud. So every single command is actually a different binary package. And this is the way he organized it. So inside of command, you will have a different directory per binary, and a different, inside you will define the main package all the time. So when you do go get of this, and every single one of these packages will actually generate a different binary. But if you don't care about this, you can still do a go get of the package part and just reuse the important part, the part that you care about.
So I do go get to GitHub Fitz and I get the package and the commands.
Yeah, you get everything. But if you, for instance, you have a package, different project and you're using only the auth thing, you could have github.com/bradfitz/cambistore/package/auth.
Okay.
And if someone does go get of your code, you could actually get just that part of code.
Okay.
You would actually only care about the good part of code. Okay, now we're going to talk about APIs. We talked a little bit before because the shorter event part is actually also about APIs. But the first thing is that you should ask for what you need. And by that, I mean, we can imagine the example from before. We had dump to file into a writer. So dump into a writer. But we can imagine dump to file and pass OS file, because actually our code, what it's going to be doing is just dumping into file. And probably what we're actually going to be doing inside of that file is just using write. If you're only using write, probably it's a good idea just to use a write. Why? Because it actually makes your code more reusable. And not only it makes it more reusable, it actually makes it easily testable. If you're passing a concrete type, writing test for .code will be difficult, because you cannot, if it's a concrete type, you have to pass that type. That's it. You cannot pass anything else. If it's an interface, you can very easily write modules that implement that interface, and you can test that code very easily.
Do you have a rule of thumb when to use an interface and when to use a type when you're exposing an API?
So I would say that you should use so if you use types, then you can define methods on it.
Yes.
So that's something that it's useful. You can create types that you can return a type and then have a bunch of methods in it. If you're actually exposing something that's more like an algorithm, so something you are doing things on an object, okay, it's better to just request an interface. Because in that case, yeah, you can very easily just do pass anything that you want. Okay. Very often, I personally prefer to expose interfaces rather than concrete types. But sometimes just doing interfaces for every single concrete type is just overkilling it.
Yeah. By interface on the long run will probably, if you want to change the implementation below.
Yeah, that's why it's easier. It's easier to test, and I think it's easier to document too. Like, just get a very nice list of methods that you can call on. Okay, something that is this part of some code that I wrote. This is actually probably the first project that I wrote in Go, and might be not really nice, but whatever, this is what we have. So the example here, I was trying to write a web app, and the application had two different parts. So the application was, you get to this web page that has a text field, and you write a function inside of it. That function gets parsed into some executable thing, and it gets plotted into an image. So there's two parts. One is parsing it, and then the other one is actually drawing it into an image. So I have this code where I create this parser that I pass the text, and it returns a function and an error if the parser failed. And then I call draw, and I pass that function, and then the size of the image that I want to generate. And then I get an image, and then I encode that image in the standard output, and there you go. Now, if you think about this, very probably at least what I did, is the parser.parse returns a function, which is a concrete type, and then the drawer gets a function. So draw has a dependency on parser. Drawer has a dependency on parser. And that's, if you come from other languages, especially like Java or C++, this is the first thing that you think about. It's like drawer has to depend on it because it gets a parameter of that type. So let's see our parsing. There's this parse func that has the text and then an eval function that it's actually the one that you can call to get, so for a value of x, what's the value of y? And in parse, I actually just called parse that does some magic. And then I return that parse function. And on parse function, you can call eval, that it just calls the eval function inside, and string to print the text. So this is a concrete type, pretty simple and usable. Now, in drawing, you could have something like this, and draw parse func. So it draws a parse function and returns an image. But you could also have something slightly more interesting, which could be, you declare a new type, which is a function, that requires only one method, which is eval. So you say, I want something on which I can call eval, and I don't care what it is. I just want something where I can call eval for values of x and get values of y. That's what you need. And then you say, and I want that function. Now in here we don't have any reference to the parser. And actually now our parser and our drawer are completely independent. And that's something really nice, because now testing the drawer, very easy. You could create a test function, which is again function, and if you call eval on it, just evaluate the function that is inside. And you could say, okay, so I want to have this identity function that it just, if I get x, I return x, and I also want to use the sinus function. And now you could actually draw your identity function and check that it is what you expect, or you could have the sinus function and check that that is what you expect, without having to depend on the parsing part. So all your tests become more unit tests rather than checking everything at the same time. Okay, concurrency is something that is very nice. You all may agree with this, but using concurrency in APIs is not always a good idea, because let's see this thing that we're doing here. We want to do something concurrently. So what we do is we pass a channel of errors, and we say, okay, so what you do is you start your job concurrently, and once you're done, I want you to send the error on that channel, and I will be listening. I will be reading from that channel, waiting for you. So what we do, we just print something, and then we sleep for a second, and once we're done, we send the message, whoops, something went wrong, into that. Okay. Actually, let me go back to the other one, so I can actually run it. There you go. Okay, and the rest, in here we have jobs, our jobs 1, 2, and 3. We create this channel of errors, and then for every job we just send it, so we do something concurrently, and then we wait for those channels to finish, so we get the errors that came back, and we print them. That's it. Very simple, and we run it. And it works. There you go. everything went wrong. So,
That's fine.
which is good. So now the problem is that so this is actually a not too bad API that you can use if you're running something concurrently. But what if you wanted to use this linearly? Like you wanted to wait for every single job to finish. You could actually have to create either different channels or do it like you should have to think about it. How do you do this to adapt it to a sequential method? Now, if you do it the other way around, and your do is not concurrent, it just does what it has to do and return the error. Using it sequentially, it's obvious. You call the function, that's it. And doing it concurrently, it's actually still very easy to do. So what we do is we just create the channel as before, and for every single job, we call the function do inside of a new Goroutine. So this is the part where we define this function, which is a function literal. We're calling that function, and we're calling that in a different Goroutine, so we'll have to wait for it. And then, as before, we just wait for the errors to come back. So the concurrent version is the complexity of the code is equivalent to what we had before, but the sequential version is way easier than before. It's just calling the function. So in general, it's a good idea to avoid having concurrency on your APIs.
I want to point out a subtle thing here that you're passing job as a parameter to the function. Otherwise, something would go really bad.
Yeah, if you did, you could just run job 3 times, the same one. So this is actually interesting. If I was doing just like this, and I run this, doing job 3, 3, and 3, what happened here? Well, the thing that happened is that we're actually using job, and job is a variable that is shared by all the iterations. And it's something that is part of the language, and it's the way it is. So if you want to have something different for every single one, what you could have is, there's either what I had before, so you actually pass the function as a parameter, so the parameter is actually a copy of the string, so you get a new string. The other option is to have something like this, which I think is pretty ugly, but it also works. So what you're doing is declaring a new variable, which is a local variable, job. That is the value of job. So now you have a different job.
Would you want that in the Goroutine?
This doesn't work.
You need to move it down a line into the.
Yeah, into the Goroutine.
It's not being closed over.
Oh yeah, you're right. No, actually.
Yeah, I think that would have the same problem.
I think you
yeah,
need
it'll
a
be
new
closed over, won't it?
So if you declare a new one, oh yeah, because yeah, I think it's because when you copy a string, strings are immutable, so probably what I'm doing is wrong. Yeah, so it's better just like just to pass it as a parameter. So you're sure that the function will get inside a new copy instead of the actual variable here. Okay, so since we're talking about concurrency, there's the best practice was avoid it, but not always, of course. So there's something we do pretty often, which is attaching Goroutines to objects, to values. So imagine that we have this server, and the server has some Goroutine that is running all the time. So what we're doing is, in general, every second we're just running a task. And if we get a quit message, then we say, okay, we're finishing the task because someone said you have to finish. So we said, oh, I'm finishing the task. You wait. Then I said, okay, now I'm done. And then you just send a message. Why are we doing this? So if we check the close, the stop function, what stop is doing is sending a message to the server and saying, okay, please stop. And then reading from the server again, saying, and let me know when you're done. Because imagine that you have some cleanup to do with the server, you want to close some files or whatever. You don't want the main function to finish too early. So this is a way to do it. This is actually a way to do it that works only for when you have only one, so you only have one object sending the stop. If you have more than one Goroutine sending stop at the same time, this is going to work. Instead, what you should do is actually send the quit could be a channel of channels. So you actually send a message saying, okay, send this, and when you're done, just answer in the same one. Or, even better, you could actually have a different Goroutine here, a different channel. So you could actually send a quit from one place, and then a different channel could be closed as soon as the server is stopped. So any call to stop would just return directly.
And so note that the runtime, if there are Goroutine running and runtime finishes, it doesn't wait for anyone.
Yeah, if the main function finishes, the whole program finishes. So if you have to do some cleanup, then you should wait for it. And normally the way to wait for something to happen is using channels. And you let someone write into the channel you're reading it. And finally, there's something that you may have seen before. It's the Goroutine leaks. And this is something that happens. So let's see this code. So my main function, what I'm doing is I have two addresses, and I have this method, broadcast message. And broadcast message, what it does, it sends this message, hi, to a list of addresses. And then I wait, and if everything went fine, then I print everything went fine, otherwise I print an error. And the way I implemented broadcast message, it's actually using send message, so send message is not really important. What we're doing is creating a connection and writing the message into that connection, making sure that we close the connection at the end with the error. So the important thing here is that broadcast message, we're creating a new channel of errors, and then for every single address, we call send message. And as soon as we're done sending the message, we print, okay, we're done. And then on the other side, we wait for it. And as soon as we get an error from the error channel, which is not nil, we return. Now, if we run this, we get only one domain. Permission denied because I'm trying to open a connection from the playground, and you cannot do this. But still, it's an error, so good enough. So the thing is that we get only one domain, and we started two Goroutines. So what happened with the second one? So what happened with the second one is that the second one is still blocked here. It's still trying to write that error that was probably nil or probably permission denied into that channel. But since we returned, we're not reading anymore. So that Goroutine is blocked trying to write to a channel and keeping a reference to that channel, but nobody will read from that. So that means that that channel will be alive and the routine will be blocked forever. So this is a routine leak, yeah.
So is this identical to the Unix concept of a zombie?
Pretty much. Yeah, except for I don't really know exactly all the details of the zombie processes, but the problem here is that yeah, you will have something that it's waiting for something to happen, like it's trying to die but not getting there. So
okay.
Yeah. So
is it something the runtime can detect?
It's something that the runtime could detect by being less performant. So
yeah.
Yeah. Instead, we have ways to solve this. So one of the ways is just using buffer channels. So what we do here is we know how many addresses there are, and we say that the channel is buffered to have as many values as we have. And then running an error into the channel will never block because we have n Goroutines. The channel accepts n values, so all the Goroutines, as soon as they're done, they can actually write that value into the channel, even if we don't read it. That means that when we return here, the second Goroutine will have actually written its value into the error channel and will finish. Then we will just remove, nobody will be keeping any reference to that channel, and the channel, even if it's not empty, will be garbage collected.
What if you just didn't return in the error handling and you handled it?
Yeah, then it would work. Yeah, could be a different way to do it.
But then you could block if there's not enough errors for you to.
Yeah, I mean, in this case, you know that everybody's gonna send an error, so you can just go through all the errors and keep track of if some error happened. Yeah.
So when range iterates over, you iterate over the addresses, so you should be fine.
Yeah, iterate over the addresses so as many times as.
Yes.
Yeah.
But will you fall through to that range before the Goroutine is finished running?
Yeah. So in what we were doing before, that Goroutine was not ever finished.
Right. Okay.
So in this case, we have to wait for Goroutine to write, because if the channel is empty, we block.
Right.
But they don't have to wait for us to read to be able to write.
Okay.
So now if we run this, we get 2 dons, and then 1 error, which is permission denied, and then we stop. If we got the second error, it could be also permission denied, probably. Now, this is a way to do it. There's another way to do it, which is using quit channels. So a quit channel is pretty much the same idea, except that in this case, we're going to use, very often you will see channel booleans instead. We don't actually care about what you can put inside of this channel, because we're going to use the channel as a signal only. So what we do with the channel, it's just closing the channel. When you read from a channel, if the channel is empty, you block. But if the channel is closed, you don't block anymore. So closing the channel unblocks all the reads. So what we do is broadcast message. We have this channel of errors before, and this quit channel. And we say as soon as we exit the function, we want to close that channel. Now, the error here, the function that we were doing before, we're doing 2 things at the same time. We're trying to write into the error channel the result of sending a message, and we might block here forever if nobody's reading. But at the same time, we're trying to read from quit. And as soon as quit is closed, we'll be able to read from this. And if that happens, then we print quit, and we get out of the select, and we're done. And on the other side, it's exactly the same. So now if we run this, we'll get done and quit directly. Because the first one will return an error. That error will be non-nil, so we will return. Returning from this function will actually close the channel, and closing the channel will make this Goroutine finish. The good thing with this pattern is that you could have as many addresses, as many Goroutines at the same time, and you don't have to send as many values our Goroutine are. Instead, just close the channel, and that acts as a broadcast to all the Goroutines at the same time. And I think this might be it. Yep. So this is a little bit of the little list of the 12 Goroutines. The 12 Gophers best practices that we're talking today. So yeah, I think that the most important part is avoiding the repetition. But when you avoid repetition, you have to be careful about the fact that avoiding repetition, even if it makes your code probably more readable, it could actually hide some complexity or even bring some loss of performance. So you have to be careful about it, about what you do exactly. And also document your code a lot. So I added some links. Last time I gave this talk, there were a lot of questions, and the answer to a lot of questions were those talks. So I just added it here. So if you're interested, there's actually this talk that I think it's a very cool talk about lexical scanning.
Oh, the Rob Pike one.
Yeah, by Rob Pike, and this is actually a very good talk. If you haven't seen it, please watch it. And concurrency is not parallelism, and concurrency patterns and advanced concurrency patterns. I think that the 4 of them are really, really good, so definitely worth a watch. So thank you very much.
Thank you.
You have a question?
So when you do the if error is nil, I remember a while back when I worked at Intel, the CPU was doing branch prediction. It was always predicting taken, which is exactly the opposite of that. So do you know if it generates more branch predictions or not?
If you do if error equals nil instead of error different of nil?
Yeah, because well, I remember that, that's way back. Maybe I'm wrong.
Yeah.
Things has changed. So, but usually when the CPU sees an if, it will always assume it's going to be true and then do the branch prediction to that side. But usually we assume that error is not going to be nil because we hope that most of our program will not fail all the time.
The compiler should optimize for that, though. It shouldn't be a matter of doing it in the code.
I don't think that there's I don't know the details about the implementation of the compiler depending on the prediction of the branches.
I would guess you're probably right that the compiler assumes the error is most likely going to be nil and optimizes that way.
I don't know if there's any optimization done in that side. Probably it's a good place to optimize if it hasn't done, because most of the time indeed errors are nil. So yeah, probably.
Okay.
But it shouldn't matter how you write it, like in the code, because the compiler should be smart enough to determine what the branch is doing.
How can it do it? It doesn't know the compiler itself, unless a JIT compiler can do that because it runs the code and know how much time it was yes or no. But once you statically compile something, you have no idea if, say, if something, you have no idea if something is going to be true or false.
Well, if you're comparing an error to nil, the compiler can determine whether.
Well,
or not.
yeah,
That's a very,
that's a
very,
specific
very
case.
specific case.
Right, but I mean that's the case you're talking about.
Yeah.
Yes.
Then take different action.
But it's not really called error. If you go for the convention of like.
No, you could actually check something like if this is actually the of type error, but then again, error is an interface and there's a lot of types implementing error, so you need a lot of information to be able to do that. I don't think it's done, and I'm not sure it could be worth doing it. I don't know.
Well, the cost of branch misprediction was really big, so it had a lot of performance. But this is at least 10 years ago, so I think it changed. Or not, still x86, you know.
Not really sure about the details. Sorry. Yeah.
I got a question somewhat tangential, but you're talking about good API design. One thing that I struggle with is things that have types that are exported, obviously capitalized.
Yeah.
Do you ever have types that are exported, but you don't really intend the user to like look into them, so you make them lowercase? So it's, they're using something that's like used in the API, maybe like your function returns lowercase type, and that way the user can't like.
You can do something that is kind of similar, which is return a concrete type, but actually you return a concrete type, and in the signature, instead of saying that concrete type, you use an interface, and the interface is something that is exported, but the concrete type is private. So you can that way you can hide all the you can hide everything on you want and just show them. So though there's examples of that. Everything that I'm thinking is Google only.
Sure.
But yeah, if you create a connection to some kind of service, like very probably you have some like
a handler or something.
Yeah, you have a handler and you have the stub on one side and the server on the other, and you actually have just like an interface, and you don't know if you're actually talking through the network or not, and you shouldn't care about that. So instead, you just get an interface.
I think, if I remember correctly, you can also have a type that's exported, but all the fields inside it are not.
Yeah,
like,
that
that's
happens too. Like if you check file, the file type on OS, it's actually a struct. So it's a concrete type, but everything inside is hidden.
Does
right.
that
So then in
mean
the documentation, it just looks like an
so
struct. So the user knows that there's a thing called a file and like gets an idea of what it is, but they don't know anything about the internal.
And they can't create instances of it?
That file,
right.
You have all of these functions.
Except by the new file create or whatever.
But file, it says contains filter or exported fields. You cannot see anything from inside. But then you have the create a new file and everything to create them. So yeah, that's also a different way. If you want to actually expose a concrete type, but don't expose all the internal parts of it, you can have.
So I mean, the intention here is for the user never to create a file
So if he creates a file directly like that, he could create that file, but I'm pretty sure that in the documentation somewhere it says that you shouldn't do that.
Okay. This is not enforced by the API, it's just says you should just create, you shouldn't just...
It's not enforced by the API. If you wanted to enforce it, then the way to do it could be to have an interface instead, and then have your create return an interface that is...
Got it. File interface and lowercase file.
Yeah.
Thanks. Good.
No problem. Cool. Okay, thank you.
Yeah.
Okay, so
Yeah.
So is one of these yours?
yes. The newer one. I don't know. Whatever.
So I'm going to be talking about using Go with ZeroMQ. So this is me. My name is Buddy Sanage. I'm a programmer. I'm a full stack engineer, is what people call me whenever they hear about my background. That means I'm not afraid of web browsers and I'm not afraid of databases. So
I'm really afraid of web browsers.
I spent a lot of time dealing with web browsers. At first I was going to say working with web browsers, but dealing I think is really more appropriate. So a lot of my background has been optimizing websites, really, getting really few HTTP requests, and a lot of front end work. So a lot of JavaScript, Python, some Go. Haven't used Go in production, but I've used it in dev and staging, so that's pretty close. And yeah, so I really come from a front end background. So why should you listen to me? Don't. I basically I learned Go by having some time between jobs, going to golang.org, going through the tour, going through the examples, and watching a few videos, and that's about it. With ZeroMQ, I learned it I first found out about it by a Node.js talk that someone just kind of mentioned ZeroMQ as a footnote near the end. So there are definitely people in here that know Go way better than I do, and there's probably people in here that know ZeroMQ better than I do. So this is really meant to be, this is what it is, this is why I think it's cool, and if you think it's something useful, check it out. So what is this thing, ZeroMQ? So don't worry, I'm not going to actually read this. This is from the ZeroMQ guide, and they give ZeroMQ in 100 words or less. And this is great, but I'm giving a presentation, that's too many words.
That's like 99 words?
Yeah, I think 95. So I was talking to someone about ZeroMQ, and they said, ZeroMQ is almost less of a messaging queue, and it's really more just like sockets done right is really a better way to think about it. I really don't have a lot of experience dealing with things like RabbitMQ or other messaging queues. The way I understand it, it's more messaging queues tend to have another process that's being dealt with. With ZeroMQ, this is something actually dealt within a process. If the process dies, everything that's been, all the messages that are queued up within that process are just, they're gone. And yeah, I really like this definition a little bit more, it's a little more pithy. So ZeroMQ, it's all about communication. You can either have you can connect through different types of sockets, so you can have in-process communication. In Go, this probably isn't as useful because you have concurrency built in, but if you're dealing with a language that doesn't have a really nice concurrency model, that's how I understand you would use it. You have inter-process communication, where this is more of a socket-style communication. So if you have two different processes on the same machine that can talk to each other through kind of more of a socket on the file system. And then of course TCP sockets, which can communicate across, as long as you have network connectivity and the port's open, you can connect through it. And that's really how I've been using it. So that's half of it. It's just, and there's Not a whole lot that's super interesting with this part.
I think one case for intra communication can be with C extensions. So you do import C and request.
Oh, okay.
Maybe then you
Yeah.
can use with that.
Yeah, that's a good point. Yeah, to do that. There are also different types of sockets or different patterns that you can have. A request response. This is kind of your client server style of communication where you have a client, you have a server, or you have multiple clients in a server, and a request comes in, the server does work on that request and sends back a response. And this is a full duplex communication where you have the request, the client is able to send data to the server, and the server can send data back to the client. Publish subscribe. This is where you have a server that is publishing out events. This is a one-way communication, so you have a server that publishes out events and a bunch of nodes that can be listening in on for those events and do work whenever they receive it. Push-pull is similar to this. And both publish and subscribe and push-pull are just one-way communication, so you can't, through the same socket, you can't have the subscriber send something to the publisher. You have to do that through some other channel communication, another socket. Push-pull, this is where you have something that's listening for something to happen and something else that pushes to it. And dealer router is something I'm not as familiar with. The way I understand it, it's if you want to do a fan-out type of pattern where you have a process that figures out how to, it goes through round robin with a bunch of clients, and router is when you have a bunch of things that go funnel down into a single one. I might be wrong with that, but
it's like a many connection pretty much, and it keeps a state of which socket dealer went through, so that when it responds, it can actually find its way back to where it came from.
So here's an example of how you might use it. This is a really boring just echo. Whatever gets in through a socket, it just pushes back a response. So, and I'm using this library. It's a really simple just C binding. It's basically if you go to ZeroMQ's website and you look for the Go binding, this is the one they suggest. They say that version 3 of ZeroMQ isn't as well supported. I haven't run into problems with it, but I also haven't done anything super advanced either, so that might have more to do with it than anything else. And basically it just sits here, it loops forever, receives messages, prints out that it got it, what that message was, and just sends that response straight back. Here's a client of it, so, and right here when you're creating a socket, you're telling it the type of socket it is, so this is the response, this is the server, this is the one that's getting the response. And then bind is what the socket is, so that makes this binding to. Kind of does what you would assume it would.
Doesn't guarantee, like if you send like a gigabyte, it will guarantee it comes back in one piece?
Yes. And that's handled by the ZeroMQ magic. It doesn't matter how big it is, it just continues the stream.
So it's not like a, okay, it's like socket's like inaccurate, it's kind of like a much higher level.
Right, yeah. It's a higher level abstraction on top of the socket. Like you don't have to deal with some of the pain that you would. And with client, this just goes through, loops through 0 through 10. It makes requests. And we'll just send out message, and whatever the number is, pushes out. When it gets a response, it will just print out that it got the response. So let's do a demo of it. So
Like the lambda in your prompt.
Yeah. Yeah, I found out that you use Unicode in your prompts. And just
A serious game changer.
yeah. Hey, this is serious, all right. So it doesn't matter what order it starts in, it will just continue to send it back. So if I start up the client and the server's not going, it's going to sit and keep that message in an internal queue, wait until the server magically appears and respond with a message. You can also handle multiple requests coming in, so you can see them interspersed with whatever order they end up coming in on.
Does the client have to have ZeroMQ as well? If it's running on top of a socket, or in other words,
it
for some of
does.
the others, it does. Okay.
Yeah, it's a really simple C library, so it's something that there are a ton of bindings for. So hopefully, whatever you're using will be a binding for it. Which is actually one of the things I think is really cool about ZeroMQ is that I don't know about you guys, but I've never worked in an environment that had a single homogeneous programming language that they use. It's normally a collection of a bunch of different programs, a bunch of people have written, half of which were written by people who no longer work here. That's going to be a fairly common practice.
Yeah, I guess I was thinking in terms of running a service that
Yeah.
anonymous clients could connect to. On the service side, you could use something like ZeroMQ, but you would never know what the client could potentially try to connect with.
Yeah, so
Does it sound like that's possible?
So there is something that's very similar. There's a web server called, I think it's Mongrel2, and that basically just exposes a ZeroMQ socket, and whatever you want to write your application in can be in the language you want. The web server doesn't care. It just gets a request from, so the server does a publish subscribe. So it publishes out, and whatever your application is just has to do a push to.
But still use ZeroMQ.
Yeah, it uses ZeroMQ to kind of orchestrate the HTTP server to whatever the application server is.
I think if you know the internals, you could probably mock what the client is doing. In socket, but that's missing the point. Right?
Yeah. Like there.
Yeah.
It is a pretty thin wrapper. Like I'm less familiar with the sockets. I've done more with the TCP, and TCP it's really just adding some metadata to the TCP packets. So it's a pretty thin wrapper.
Okay.
So pretty simple, but yeah, the cool part is you have different languages. So here's the Node.js example. That's pretty much the same thing. Instead of going from 0 to 10, it just continues to go until the process dies. So requires ZeroMQ, sets the socket as a require socket. This is a little bit, if you're familiar with JavaScript and Node, it's a pretty common pattern just having event emitters. So whenever the socket receives a message, it calls this function, and then just continues to loop over this function every 100 milliseconds, sending out whatever the count is. Here I can actually just keep this guy going and just call my client and just continues to send it out. And if the server goes away for whatever reason, it continues to send out these requests. It's fine, it's just going to keep that in memory. So once the server reappears, you're going to get all of the server's going to go handle it and deal with that as if nothing ever happens.
Yeah, I work with ZeroMQ at a previous job where they had lots of different
processes talking back and forth to each other. But if you're on a specific service and you're sending a whole bunch of things to another thing and you die, all your messages die.
Yes.
And this was a company that was dealing with emails. And it's like if your email doesn't get from point A to point B, that's a problem.
Yeah.
If it's like a password reset or that kind of thing.
Yeah.
So, and I found that ZeroMQ was really fascinating, especially for this property which you mentioned entitled "The server doesn't have to exist for the client to keep on sending stuff."
Right.
But I couldn't figure out exactly how to say ZeroMQ. Okay, you can only send X number or X bytes of stuff. Otherwise, you need to block because I don't want you to die with this stuff being gone. At least in my experience when I was working with this, it seemed like ZeroMQ hated disk. I was wondering what your knowledge is on this.
So you do bring up a really good point, and I was actually going to give an example of what you can go wrong when you're just using request response. So I know there are ways to get a reliable request response pattern, because you can also mix together some of the different patterns, so you can have a response hook up to, or a request pattern socket hook up to a dealer socket. Like, it doesn't have to be a request to response. I know that there are ways that you can get a reliable request response where if the application server just dies and you bring it back up, it can still work the way that you would hope it would. I haven't implemented them, I just kind of know they exist, so.
Okay, thank you.
Yeah. So here's actually an example of what can go wrong. So this is crashy, flaky Echo server. So it's the exact same version, except if for some reason you get 10 in, it just panics.
I think I run this code.
I've actually written this. So yeah, this is something that when I first found, well, I'll show you what actually ends up happening when you try to run this. So let me see. I love how fast Go compiles. Alright, so we have a crashy or a flaky request, and if I go to our client and run it, it's fine. It doesn't get to 10, and you can run all day, it's fine. Let's say we actually go to our Node version and run that. It crashes, but it's still sending stuff. So if we just start it up again, yeah, it's not actually doing. It's waiting for requests to come in, even though it looks like it's sending a bunch of requests and it's not happening. And if I start at the client again, it starts, but it starts over at 0, so you lost all the previous state. So what happened there? So basically what happened is request response is kind of a blocking operation. When a server gets a request in and a client, it pushes another request, it doesn't start working on request number 2 until it gives a response for request number 1. So that means that a request comes in, it crashes the server, and the client is still waiting to get a response back so it can send request number 2. But that response never actually ends up getting set, so you end up in this kind of stuck situation. This is where the project that I was working on, where I was using Go with ZeroMQ, when I discovered this problem, I the first way I tried to solve it was having a client and a server where the client had a pub sub going in one direction and the server had pub sub going in another direction, and you can just, since it was a pretty small site and really using this architecture was probably pretty overkill for that project. But I got to use it and I wanted to use this stuff, so I went for it. And I was running into some problems with that approach, and then the project got canceled, so I didn't find a good solution. Yeah, so another reason you might be interested in using ZeroMQ is if there exists some library that is really good in another language, but you don't want your entire program to be in another language. So, for example, Socket.io, which, if you guys aren't familiar, is a Node.js package that makes WebSockets really easy to deal with. WebSockets aren't available in all browsers, so Socket.io can deal with legacy browsers by using long polling. Believe it or not all browsers correctly implement the standard, which, a web browser not implementing standard is shocking me. Right. So Socket.io, is really the go-to web socket library that really solve all these problems for you, and it's a great tool to use. So in the case where I was using it, I was using a Node.js front-end server, and Go for all the back-end logic, and the front-end just handed requests to the back-end and just dealt with all the front-end web stuff in there. So here's an example of how we can kind of...
What was the latency like?
The latency?
Yeah, doing that.
That was actually really quick. So it was a pretty small site, so everything could just stay on one server. So it wasn't actually going over the network, which really helped out a lot. Just having I/O on the server itself was more of a bottleneck than any of this. So first I was going, so let me give an example. So this is something that is called broadcast. I called it broadcast because I was originally going to make it a publish subscribe, but I realized that that wasn't really going to work. And that's because this is a client, it's a command line program, and publish is really meant to be kind of something that stays around for a while, and you would have so the idea was I would have a web server that would get a request from this command line, or really any type of program. In this case it was a command line utility, and that would send a message to the web server, and the web server would push it up to the web client. So I was thinking, okay, I'll just publish out an event, the web server can listen to it, and once it gets that event, send the data to the web server. But that's actually really more of a push-pull model. After it not working, I realized that that's what the problem was, so this is actually just pushing it out. And all that's going on here is creates a new ZeroMQ socket, makes it a push, connects it to the web server, and just takes all the command line arguments and joins them together and sends it across. And tells you what it's sent, and it is really done. On the Node side, this is kind of broken into two parts. So here we're just defining the libraries that we're using. We're creating instances of the library, and we're this messages array. So this is all the messages that have been sent while the server's been running. The handler, I'm creating a server with this handler, and all it does is set the content type, say it's 200, and send out a HTML file. No matter what URL you hit, you're just going to get the same index HTML file. And so what's happening here, this is the last part. The poll is a poll socket. it's binding on localhost 4000. That is the HTTP server, so it's listening on 8888. Whenever the poll gets a message event, it adds the message as a string to the messages array. This IO socket says whenever a web browser connects to the server, it has a new connection, so it makes a new WebSocket. Emit message is a function that just sends out through the WebSocket a news event and sends out a message, sends out what the message was. When a server connects, it goes through every messages and emits it. This is really codename for a demo. Like, this has really obvious problems, like messages are going to grow forever. But whatever, it's a demo. It can be termed a demo. And then, so whenever a poll event happens here, so it both happens for everything, so even if nothing's connected, or a connection is made, it will log out the message, emit it, and then this is just showing that the WebSockets are full duplex, so if the WebSocket gets an event from the client, it just logs it out. This is the actual index HTML, or at least the interesting part of it. So here we just have a table with a log. It's a table because it's really easy to make striped output with using Bootstrap. And jQuery is probably also overkill for this, but it makes it like a few lines, so whatever. So it connects to localhost, and whenever it receives a news message, which is what is emitted from this emit message guy, whenever it gets a new message, it just puts a new row in the table right before, at the top of it, and also emits back what it got, just to kind of show that's working. So, let me give an example of that. So, let me pump this up a little, and let me actually. So here we have Chrome, Concurrent, and Firefox. All this Debian says Iceweasel, but it's Firefox. So here, it just instantly gets pushed out to everything. I was kind of playing around with this. And realized that there was no reason that you had to limit, since it was just pushing it right on through, so you could just do something like,
Oh no.
Alert safe.
Right, I mean, and you can also do something really bad, like,
Throw a little JavaScript.
Yeah. Helps if I start the script tag. So like this, oh, why is this so familiar? People are watching me, so I've lost my ability to type. And I have a closing quote, but whatever, it still works. And here we see, hey, look at that. So yeah, this is, like I said, demo code, but you can also do something.
You could find it in some production servers out there in the wild if you really.
I'm sure you could, but you can also do some other stuff. So here I'm going to broadcast out an image with a data URL.
Sweet.
And just base64 code an image from earlier, and this guy seems to have lost it. I don't know what's going on there, but just conquer what he expects. And yeah, and also you can also see the basic Z4 encoded image. If we go over to where it's running, which is 6, you can see it's sending out or getting back the data from the server. I probably should have showed it before I had the big image, but there we go. Second half. So, any questions or I'll show it.
Just answering your question, I think one of the advantages of ZeroMQ has binding to so many languages. So you can tell people, just use ZeroMQ, and like if they're using roughly a mainstream language, they have it already, and then they can do a lot of stuff, and it's really nice. I think the guy, it's a C++ library from what I remember.
C.
C.
Yeah.
So
he wrote it in C++ and then changed it to C.
He wrote AMQP, whatever it's called, and then built ZeroMQ when he realized it sucked and did it in C rather than C++.
Yeah, he has a famous article about why not C++, and he gives a lot of reasons why I chose C for that. So if you love C++ like me, it was a good reason.
Yeah, something else I think is really cool is the way that you can kind of introduce something like Go or some other language that may not be as popular. And I'm a big fan of having really small applications that kind of compose together. So it's a way that you can kind of use it to infiltrate what the languages and tools that you want to use.
One thing that wasn't obvious from the code, in ZeroMQ you can prefix like a tag, and then the message itself, which is just a string, and then you can subscribe only to these kind of messages. So it's built in. I think you have it there on the message from server or something like that you subscribe just for that kind of messages. Event from the server, event from the browser. Yeah. So this one is basically just it's a very simple routing that you can do, and you got it for free.
Yeah. In this example, this one is actually coming from a WebSocket.
Yeah.
But yeah, that's one of those things that falls into the category of I know you can do that with ZeroMQ and I just have it.
So those pops up like one to many. Is there like a central master that's routing all the messages to the publishers and subscribers?
Yeah. The ZeroMQ, no.
You have to have all your subscribers connect to your publisher.
Oh.
The 0 stands for no broker. That's like there's no broker in the middle. Like you need to connect.
I'd argue that the publisher is the broker, but yeah.
Yeah, actually, if you go to here they have a ZeroMQ guide, and there's also an O'Reilly book that is based off of it that is really good, and that has a lot of really good code and also a lot of examples through here. There are let me see if I can.
And I think here the examples you can pick the language.
Yeah. So if you go to the GitHub repo, you can.
I think even the guide itself, like they have tabs like you can pick Python or Java or whatever.
Oh, awesome.
If you go a bit lower
Yeah.
on this page, no, this is. I remember that there was an option.
There.
Yeah.
Oh,
here,
there is.
okay.
Wow, that's a bit different. So tiny.
Yeah.
So.
And you also ignore the arrows here.
Yeah. That's something else I was thinking. I was right. I was thinking like, there's going to be someone doing a best practices of Go, and I'm going to be doing that.
Anyone else using ZeroMQ?
I used it with Go.
Yeah.
The last
We used it in Ruby.
In Ruby?
There used to be like a really expensive like pub/sub library. I forgot what it was called. Anyway, it was before like these open source ones came out, and that was quite popular.
In which language?
It had several bindings. It was mostly it was for like embedded work, so it was mostly C, C++.
ICE?
No, I've used ICE before, but it was around that same time. I think I had MQ in it.
Warranty.
It'll come to me.
So I had a question about actually your slides. What are you using Go Docs, and how did you do that thing?
Oh,
Oh
yeah, there's
Did you modify the code or something, or what?
well, for
I mean, it's open source, so it's awesome, but I'm just curious about how you did it.
So which part of it?
So the part where you have the, I guess it's
The HTML inside the slide?
Oh, yeah. There's a iframe. So let me.
I think you could put HTML directly inside the slide.
Yeah, let me see.
I think that's what you can do, but you'll know in a minute.
Yeah.
Go ahead.
All right. Yeah, so with that, I'm just using an iframe to.
So the iframe is part of the.
Yeah.
I never paid attention to that.
Yeah, so I'm just following the instructions right here.
Yeah.
So that's how I did it. And also these slides are on the Going or the LA Go.
Yeah. So we have a GitHub repo with all the talks. I'll add yours if it's.
I have it's already online. So
yeah, I just add the link to that. Yeah,
sure.
There's LAG talks. LAG/talks. Bit.ly LAG/talks. LA Gophers /talks.
You can add more, so I guess why not? Of course I can.
Yeah, Bit.ly.
Actually, yeah.
Do it live at this part.
Yeah.
Here, no, that's not wrong.
No.
That's the thing we just had.
Bit.ly/LAG-talks.
You know, I'm gonna use it from somewhere I can actually.
Okay. Yeah, or you can see that here. Yeah. LA Go Meetup/talks.
So I have a question for you. Where do you see the worst case that you should never ever use something like ZeroMQ?
So I'm still kind of a newbie with it. So
I've had a lot of beer, so just do this. And see.
okay, I don't.
It's really bad for waving your hands around.
Yeah.
Yeah.
So yeah,
Yeah,
but
so-
LA Go meetups. There's.
Yeah. So this is the repo. We have all the talks there. Should put a link to the videos itself. There's a YouTube playlist. All of this is getting there. So.
Okay.
Yeah.
So one possibility would be the example I gave earlier entitled reliable communication from point A to point B.
Yes.
I think the solution you gave entitled use a couple different types of these super sockets, where one is reliable and the other one you transfer most of the data. I think that's actually an excellent solution. Whereas another solution is, say, screw it, and you use something like Redis, where you communicate, okay, there's this block over in the queue with this ID, go process it. And that might or might not be a better solution. I'm just kind of, because I don't know the edge cases for Go or for ZeroMQ. I'm kind of curious what people think about when you would use it, when you would not use it.
I think if you want state when the server crashes, then you either go with one of the already queuing systems with the other, like Rabbit or whatever you prefer. One thing to do it with ZeroMQ is probably, save its own on disk, wait until you get an acknowledge that it was fast, and then you throw it from the queue. But then you're basically implementing a queue on top of ZeroMQ. So
That's sort of my experience. I understood that ZeroMQ said that if you get beyond a certain number of bytes, then write it out to disk. That it looked like the technique of when you create a socket, read it back on the disk was the trust me kind of thing. It didn't seem like anyone was actually using it.
Yeah.
But ZeroMQ looks fantastic for point-to-point semi-socket-ish connections. Yes. So if you're sending individual packets to a whole bunch of different servers, it looks like ZeroMQ really doesn't give you anything. So I was just kind of curious what your thought was on that.
I think like all the communication which is P2P and very much, let's call it real time, like chat rooms, messaging and stuff like that. I think for that ZeroMQ is really great because then if you're connected to your peer, you get messages. If you don't, that's it. So.
One thing I thought I read about with ZeroMQ is theoretically the efficiency is a little bit higher than TCP because TCP traditionally sends like a byte or two at a time if it can, whereas ZeroMQ buffers a little bit better and you actually transmit chunks. So in a traditional socket, if you receive 50 bytes, do you get the entire packet? Do you have to wait for end of line? Do you have to have a header, that kind of thing? Whereas ZeroMQ handles that blocking for you. So theoretically, it's actually a little bit more efficient than TCP.
Yeah, I think I've heard that can be more efficient, but I didn't know the details.
Yeah,
So that's really.
I was just hoping that it just sounded cool, so I thought I'd mention it.
Yeah, like I said, I'm not an expert on the subject.
Sure.
It's really more about like, hey, I think this is cool. Check it out.
Yeah, that was my experience also.
Okay,
I did a talk on AMQP for the Python thing a while back, and I switched basically to ZeroMQ because I found the idea of having a broker was a little sketchy. And it seemed like the ZeroMQ types were very opinionated bastards who really didn't like AMQP. I'm like, okay, you know. Yeah. And the multiple language thing with ZeroMQ I thought was really awesome.
Yeah, I see ZeroMQ used for a log thing, like where if you want to just have another service that is really small and really reliable to and have that keep track of your message queue. Yeah, part of my opinion is that like things are going to break. Things are going to go wrong. That's just gonna happen. So I guess I'd suggest to kind of know that that's gonna happen and try to architect things in a way where they can handle, you know, not have single point failure, the traditional like just good architecture stuff.
Okay.
But yeah, I mean that's it for me. But
Question for is there a plan to bring back the netchan package?
So
the netchan package, just an overview if you don't know that, was channels between processors and between machines.
Yeah. So I was thinking about it because I would be curious about what's the actual difference between ZeroMQ and channels. And so if channels were removed from the standard library, not channels, sorry, net channels were removed from the standard library, it was because if you use channels on things that can fail, handling the error, it's actually not obvious. And so that's why, pretty much. Channels make a lot of sense when you're inside of a process where communicated from one side of the other to the other of one single process. It always works. And if it doesn't work, then everything should fail. But if you add a connection in the middle, network connection in the middle, the errors are very difficult to handle. So that's why it was removed. And it's still the case. So there's actually a pretty cool implementation. There's an article, I guess that you've seen it, about how to implement the net channels.
Okay.
So net channels. And it's a very good blog post, and you can use it, but at the same time, the problem is that when it fails, it just fails, and you don't know exactly how. And handling the errors is really difficult. You're just reading from one channel, and all of a sudden that channel closes.
Yes. How does Erlang do that? Because Erlang has this message passing between processes.
I don't know, and I should check that. Yeah. I don't really know. I'm actually learning Erlang like in 2 weeks. So
yeah. Yeah, there was a good talk that came out from Joe Armstrong. He wrote Erlang about how to write distributed system in a way that you get 9,000 lines or something like that. And,
Yeah.
yeah, it was like a lot of lines. And he's talking about Erlang and all
I mean,
that.
Erlang is designed specifically for like communication over the network.
Yes.
And,
Yeah.
I mean, like I'm sure it's built with that in mind, and that's why it's designed to not fail in that way.
Yeah, I should check that. Like, what happens if you have a channel over the network in Erlang and then the network goes down? What happens there?
I play with it, I don't remember. But for me, one of the things that I wanted a system that does channel and a lot of concurrency and things like that. And Erlang provides that, but the syntax was like, oh god. And then Go came and I said, okay, that I can do better.
Yeah, you can. There's implementations of net channels, and you can use them. But we don't want to have them as part of the standard library because of we don't think that it's actually a very good design because you're hiding the errors.
Okay.
And that's something that shouldn't be done. So hiding or ignoring errors is something that shouldn't be ever done, except for demos, of course. Yeah, I should check that.
It was NDDS I was referring to before. I don't know if anyone's ever
I
heard of
never
that.
heard of it.
It was like the payware version of this before it was all open source.
Any questions before we go to shutdown? That was really appropriate, I have to tell you. Like, that was really... All right, thank you very much, buddy, and Francesc, for coming over. You're welcome to stay and socialize, do damage to the pizza and the beer or the fridge there. Thank you very much. And we'll see you next time.
Thank you.